In our last few videos, we've been looking at the process of ossification, or osteogenesis, that is, the formation of the bony skeleton. We said that there are two main types of ossification that correspond with the two original frameworks, or scaffolds, that form the original basis of our bony skeleton. There's endochondral ossification, which replaces hyaline cartilage with bony tissue, and there's intramembranous ossification, which replaces fibrous membranes with bony tissue. After that original framework is formed, the skeleton must continue to grow all the way through early adulthood, and then throughout life the bones are continuously remodeled and repaired. Our previous videos focused on endochondral and intramembranous ossification. This current video is going to focus on postnatal bone growth, and future videos are going to look at remodel and repair. Longitudinal bone growth, that is, an increase in the length of bones, is very similar to endochondral ossification, so it might be useful to go back and review what happens during endochondral ossification before moving forward with this process. Longitudinal growth relies on the presence of epiphyseal cartilage plates, or growth plates, that connect the epiphysis to the diaphysis. Here, we're looking at a plate of hyaline cartilage, which is why the steps are so similar to endochondral ossification. Let's zoom in and focus in on this growth plate. The side of this growth plate that faces the epiphysis is relatively inactive and is called the resting zone. But deep to that, there are 4 different zones that are organized with cells doing particular activities that allow for fast growth. Directly beneath the resting zone is an area called the proliferation zone. Here, the chondroblasts, the cells that make new hyaline cartilage matrix, are rapidly dividing by mitosis, building a number of cells. And then, following that, is an area called the hypertrophic zone. In this hypertrophic zone, the chondroblasts start to enlarge and expand. That expansion of the chondroblasts serves as a signal to start to convert the hyaline cartilage matrix into a calcified form. So, following that hypertrophic zone is an area called the calcification zone. Here, the hyaline cartilage matrix is being replaced by calcified tissue, and because nutrients don't dissolve through calcified tissue very well, the chondroblasts start to die. This forms hollow openings or kind of spicule formations in the forming bone. Those openings allow red marrow elements, especially osteoclasts and osteoblasts, to invade this area. The osteoclasts break down some of that calcified material, and the osteoblasts replace it with true bony tissue, which is why this 4th area is called the ossification zone. We're replacing calcified tissue with true bony tissue instead. During childhood, the epiphyseal plate maintains a relatively constant thickness. This is because the rate of growth on the epiphysis side of the plate is matched by ossification on the diaphysis side. As adolescence ends, the chondroblasts on the epiphyseal side start to divide less often. Meanwhile, ossification continues at the same rate on the diaphysis side. That means that the ossification zone will start to move closer and closer and closer to that resting zone of the growth plate. This combination causes the epiphyseal plate to become thinner and thinner. Eventually, the cartilage plate is completely replaced with bone, a process called plate closure, at which time the bones no longer increase in length. This happens around the age of 18 in females and around the age of 21 in males. Even though the bones have stopped increasing in length, they can still increase in diameter by the process of appositional growth. Growing bones must widen as they lengthen. Otherwise, they'll become too long and skinny and they won't be able to support very much weight. By adding more girth or width or diameter to the bones, it allows those bones to support much more weight. Bones increase in width or diameter by the process of appositional growth, which is very similar to the appositional growth we've seen in hyaline cartilage. Here, the appositional growth of bones is caused by osteoblasts that are just deep to the periosteum, secreting bone matrix against the external surface of the bones. And because of that, adding material to the outside surface, the bones will get wider and wider. Meanwhile, osteoclasts on the endosteal surface, meaning where the medullary cavity and other internal surfaces are found, will start to remove existing bone. Normally, there is slightly more buildup than there is breakdown, and because of that, the bones become thicker and stronger, but don't become too heavy. That action of the osteoclasts, breaking down the endosteal surface, is an important portion of this growth in diameter, because without that action, the bones would become thicker and thicker and thicker, but also heavier at the same time. By adding material to the outside and breaking down material from the inside, we can keep our bones growing, but also make sure they don't become too heavy. Several hormones influence growth through young adulthood. The most important is growth hormone, abbreviated as GH, and as its name indicates, it causes things to grow. This action of growth hormone is modulated by thyroid hormones such as thyroxine. The modulation by thyroid hormones helps to ensure that bones over different portions of the body are growing at relatively similar paces, so we don't have a lot of growth in one area and a very little growth in another area of the body. At puberty, sex hormones like estrogen and testosterone promote what's known as the growth spurt, but it also helps promote the development of masculine or feminine aspects of the skeletal system. For example, a wider larynx for males, which causes most males on average to have a deeper voice than females. Towards the end of puberty, though, at very high levels, sex hormones like estrogen and testosterone promote the closure of the epiphyseal plate, which ends longitudinal growth. We normally stop getting taller at the end of puberty because of these changes in hormone levels and the effects that has on what's happening with the cells within the growth plates.